Boy, in Trinidad there's a signal. God has provided a signal for us to let us know when it's time to start studying, when these exams are. Breaking up the game of trigonometry into smaller parts, smaller levels, then help you to really understand it better and to retain what you study. So I break it up into these three levels. You have like the basic level, you have the mid level, and then you have the boss level. Alright, the basic level is just the normal stuff. Radians, by the way, you must know your Pythagoras theorem and your sine, your SOHCAHTOA, assuming that you know those stuff, right? If you haven't, the last two videos I've done is on that. That's maths. But in the admaths we have radians. That's understanding a new type of circle, angular measure, radians, the arrow, not pointing it. Radians, arc lengths, area of sector, exact value of tan theta, sin theta, cos theta, popular angles. Then you have the mid level. This is where things start to get a little more exciting. You need to understand sectors here, quadrants, graphs. You need to know how we get this guy, cos squared theta plus sin squared theta, and you know how we use it. This is like the most important formula identity that we use. Then you know your compound angle and your double angle. And that's what we do for admaths. There's more for those in pure maths, but this video can still help you to just get a good footing on trigonometry to understand the concepts, and then you could take it from there. And then the boss level for admaths students is solving identities and trig equations. So let's go. The basics, radians. So radians is just another way of measuring an angle. We are accustomed in degrees, but we're introducing you to something new, radians. Radians, for those of you who are adventurous and want to know how we come about it, it's like if you have a radius here, and you set up the radius here, and you open it so that the angle makes a length, and you open it so that the angle makes a length that is equal to the radius. So it's like the radius is equal to the length there.
Daddy!
What am I?
Can you open it?
Yeah.
Can you open this? Thank you. It's slimy.
When I was taught this, I found this really interesting because you see, it's a better way to measure the angle because it ties the angle itself with the radius. So when you begin to form formulas, it makes it just easier. I know some advanced students might disagree with what I'm saying, like why should we have radians and we already have degrees? Why do we need to bring in something new? But it forms nicer equations, and you begin to, maybe you might begin to love radians more than degrees, maybe. So the first thing you need to know is how to convert radians to degrees. How do we convert radians to degrees? By the way, you see this little c here, this little small tiny c is like 1 c equal 1 radian. But it's not c, right? It's like a half a degree, whatever. So that's the symbol for radians, right? So everybody know the symbol for degrees. How do we convert? Well, the conversion is pi radians is equal to 180 degrees. And this kind of makes sense for those of y'all who want something to do extra out of the syllabus. Try and figure out why that is so, using this bit of knowledge that I told you all here. Anyhow, so pi radians is equal to 180 degrees. Let me jump into some questions one time. Convert pi over 2 radians to degrees. Now, this here could have been written as pi over 2 radians, but we write out radians, we spell out radians, and sometimes you might see RAD, that means radians as well, right? So how we converting this radians here to degrees? Simple. If we want to go from radians to degrees, start off with the conversion but write the radians first. So pi radians is equal to 180 degrees. If we wanted to go from degrees to radian, we'd write 180 degrees is equal to pi radians, right? Pi radians is equal to 180 degrees, therefore pi into radians is equal to 180 divided by 2 is equal to 90 degrees. Simple. Let me check our next question. Convert 0.7 radians to degrees. Okay, now notice just now I said pi radians, so this confuses people. They see this pi here. Because radians are tied into the relationship between the radius and the circumference, pi will pop out plenty when you're dealing with radians. So they'll just have pi instead of writing 3.14. Well, yeah, extra stuff. We can't write the extra stuff with pi, so we just write pi over 2. It makes it easier. So don't let that hot up your head, right? But sometimes you can actually write an estimation using the decimals, right? So 0.7 radians to degrees. So let's do this conversion, boys. 0.7. Well, we started off with the same pi radians equal to 180 degrees. So 1 radian is equal to 180 divided by pi. This is usually the next line you hit them. You find for 1, and everybody who knows consumer arithmetic know that you normally find for 1, right? And then you go on to your next line. Therefore, 0.7 radians is going to be equal to what? 180 over pi multiplied by 0.7. And you can use this technique for everything. Alright, this is really easy stuff, boy. Let me do one more. Oh, by the way, this is like 40.1 degrees to 1 decimal place. Yada yada yada. 180 convert 50 degrees into radians. Yeah, I wasn't seeing that. Convert 50 degrees into radians. So 180 degrees is equal to pi radians. Notice I start with the conversion facing this way. Then I find for 1 degree pi over 180. Then I find for 50 degrees. And that's the answer there. They don't know how to do them thing. Practice a few questions on that. Mash up the place. Is this a tip? That's me drawing there. Leave pi in the... So, right, yeah, remember to leave pi in your solution. Most of the time, to make things easier, just leave pi in your solution. Don't go and like multiply 3.14 by 5. Pi is not really 3.14. That's not the exact value of pi. So, and this is an exact value. If you use the pi in your calculator, you'll still end up with decimals. And pi is just such a messy, irrational number, man. Just leave pi alone. So let's go on some more into arc length and area of a sector. This is the first part of your CXC question, people. You will always get something on arc length. Not always, but 99.99. Alright. You will get something on arc length and area of the sector most of the time. Let's see the two equations that we have to use. L is equal to r theta and A is equal to half r squared theta. L here stands for the arc length and area here stands for what, boy? The area of the sector. Sector, pizza, sector. Anytime you think sector, think pizza. Don't mix up sector and segment. Segment is something else. Formula for arc length is r by theta. That's this form. These formulas are just sweet and neat. R theta. You just multiply the radius by theta, which will be the angle inside here. Just multiply the radius by theta, and boom! All of a sudden, you find the arc length. If you want to find the area, just multiply half by r squared. So multiply r by r and theta again. Bam! You have the angle. You have the area, sorry. So these formulas are just nice and neat and simple. Compare it. Do you remember the formula for in degrees for arc length? Yeah, that put theta over 360 multiplied by 2 pi r. Damn. So these formulas neater with radians. I tell you, radians is the way forward, man. Alright, what's this? This is a question. Why any form of square of size 5 centimeters is bent to form a sector of, I don't know why I do that, of a circle of radius 8 centimeters. So we had a wire that was a square, and we take the same wire and make a sector. So the perimeter of the square is equal to the perimeter of the sector, and then we need to find the circle of... This could come for C-sec. This could come for C-sec. Watch how you do this. First you find the perimeter of the square. Side by 4. Don't put side square. That is the area of a square. Side by 4 would be the perimeter of the square. Once you find the perimeter of the square, by the way, this could be for any this could be any shape. Sometimes they might start off with a rectangle or a triangle, and then you bend it up, and you're always forming a sector or some kind of thing like that. So then the length of the arc will be equal to r theta. The reason I'm finding I'm just finding this in preparation for some other things. That is 8 by, because they told us the new radius, right? This is from the question, 8 theta. And then the perimeter of the sector now would be 2 times the radius, because you have to think like this. This is the sector. It has 2 times the radius here, and then it have that length there. Simple, man, simple. Is equal to 2 by 8 plus L. This was L here, so I just put it in there. Understand what I'm doing? The perimeter of the sector is equal to twice the radius plus the plus this part here. This part here. So just find the perimeter of the whole sector. And now that perimeter is supposed to be equal to the perimeter of the square, right? According to the question. So 20 is equal to 2 by 8 plus 8 by pi. We'll call that, find for pi. And I think that's the first part of the question there. Once you find pi, everybody good enough. Once you find pi turn out to be a half. Then you can use that and find the length of the arc and the area of the arc, just plugging in these two formulas here. We didn't go waste time on that. I think everybody could kind of substitute and do the little algebra and thing. It's that much, right? So you must be able to handle a little algebra. This is the next part of trigonometry that people overlook, and it's very important. The more you understand this that I'm about to show you, is the more you understand trigonometry in a whole, and you're able to do some simple questions and tricks. People will overlook this and go immediately into the hard stuff and then get lost. These are some triangles that you need to know. Know these triangles, bro. This triangle, I think most people are familiar with it, a 3, 4, 5 triangle. That's a right angle triangle. In fact, if I drew this and I didn't put this value here, you're supposed to know that that is 5. Right? It's a common triangle. Here's the next one. 5, 12, 13. A common triangle. Right? And these kind of triangles, the knowledge of this could be tested in multiple choice. How do I get these lengths? Via Pythagoras theorem, right? 4 squared is, that's damn dog. 4 squared is 16, 3 squared is 9, and the two of them will get 25. Square root of 25 is 5, right? Pythagoras theorem, c squared equal b squared. Pythagoras theorem, c squared is equal to a squared plus b squared. So these first two triangles, people know them. Do you see this triangle here? This is the top dog triangle. So consider a triangle that you have an equilateral triangle 2, 2, 2. That means every angle inside there is 60, right? Every angle inside there is 60. Now if we split the triangle, see the green triangle here, we just cut him in. Okay. See the green triangle here, we just cut him up like that. That would mean that this part here is 1 because it's in half, and this part here is square root of 3. Now how did I get the square root of 3? You may ask. Simple. I use Pythagoras theorem, so it will be 2 squared take away 1 squared, 4 take away 1, 3 square root of that. You can try it out with Pythagoras theorem and you'll be able to figure out what this side is. Now this is going to unveil some really interesting stuff for us. It means since this angle here is 60, because remember it was an equilateral triangle, this whole angle here is 60. So half of this would be 30, right? Half of the angle there is 30. So since we know those two angles, we can assume these things. Via sine is equal to opposite over hypotenuse. Everybody know this, SOHCAHTOA. We can assume these things based off of this. The sine of the 60 will be equal to opposite over hypotenuse. And we can figure out the exact value of sine of 60, cos of 60, tan of 60, and for 30 degrees as well of that. So if I just use this, once again, this is SOHCAHTOA. We used to remember this, SOHCAHTOA. And people been texting some really weird things to remember this in the comments. I think the weirdest one I see was sex on holidays can always help teachers overcome anxiety or something like that. Weird stuff. Whatever float your boat to help you remember that in it. So via that triangle we found the exact value for sine 60, cos 60 and tan 60. Once again we just use the opposite and we use the hypotenuse based off of the triangle we drew. And we're able to figure out all of these stuff, and then we'll be able to figure out the cos, sine and tan of 30 degrees via the same logic, and it's like this. So some people fight up to, they know that for the exam you need to memorize these things, you need to know it, but it's easier to just kill two birds with one stone and learn this triangle, because you may be tested on this triangle anyhow. So learn this triangle, learn how we got 60 degrees, 30 degrees. And you use the 60 degrees here, this would be the opposite, this would be the hypotenuse, and you can immediately figure out what is the sine of 60 degrees, sine of 30 degrees, etc. All of these things with just that triangle, and you don't need to go and memorize all these things, right? But if you do enough tricks, this will just come naturally to you. You'll just kind of start to know this offhand, sine of 60 square root of 3 and 2. You may notice a little pattern taking place here. Right? That helps in memorizing. That's simply because the sine and cos are very related. They're just off by a phase of 90 degrees. So remember this is sine, and then cos will be like this. So it's basically the same style of curve, but they're off by a phase of 90 degrees, or pi and 2 radians. Final triangle that you need to know. This triangle, if we have, this is to get the 45 now, because we deal with the 30 and the 60 degrees already. This is how we create a 45 degrees triangle. If we start off like this, both sides are 1. Well, this will be square root of 2 via Pythagoras theorem. Just verify that. This will be 45 degrees, an isosceles triangle. Remember, this is 90, so these two are the shade here, remaining 90 to make 180, 45 degrees. And we can immediately find the sine of 45 degrees by looking at the opposite and looking at the hypotenuse and so on. So that gives us this. Sine of 45 degrees is equal to half cos of 45, 1 over the square root of 2, I should say. Cos of 45 degrees will be the same thing, but tan of 45 degrees is actually 1. Right? Now, this is another way to write this. Watch here. This is another way to write 1 over the square root of 2. How did we get that? It's like if we multiply top and bottom by square root of 2. We just want to get rid of the third in the denominator now. So, square root of 2 by square root of 2 is 2. And 1 times the square root of 2 is square root of 2. So, this is just another way to write that same thing. And you would see this come in your exam. This number will come in your exam more than this number here. Alright. So, let's have some fun with some graphs now, man. Y equals sine x. If we... Well, you know, the graph y equals sine x, there are some key points. There's 0, there is 180 degrees, there's 360 degrees. So you have 0 degrees, 180 degrees, 360 degrees, key points. And in between 180 and 0 we have 90 degrees, and in between 180 and 360 we have 270 degrees. If you take those points and you plug it into your calculator, press the sine of 180, you'll get 0, sine of 90, you get 1. So again, 0, 1, 0, negative 1, 0, and if we add 90 to 360, you'll get 450. This will go up to 1, and it'll keep making this kind of up, down, up, down, up, down pattern. That's the sine graph for you, and the cos graph does something similar as well. So where's my green marker? If I just draw that there, I'll get something looking like this. That's y equals sine x from 0 to 360 degrees. Now you should remember that I can, instead of saying 90 degrees, I can say pi and 2 radians. Instead of saying 180 degrees, I can say pi radians. 360 is 2 pi as well. And the sine graph will go on like that, making that kind of pattern. And we'll call each one, this will be like one phase, another phase, or a cycle, and another one. And if I want to go into the land of radians, I'll end up with something like this. Pi and 2 pi, 3 pi and 2, 2 pi for 360. Let's go on. So, this is one way to look at y equals sine x. There's a next way to look at it, and I really want you to pay attention in this part. Pay attention in this part, my friend. It's going to really help you and change your life and all those kind of things. Like this. If we have a circle, you notice we have 3 quarters in that circle. We could call them quadrants. Just like how we... Did I say 3? 4 quadrants. Right, and we have 1, 2, 3, 4 quadrants here as well between each of those key angles. So this is 90, this is 180, this would be 270, and you get the idea, right? So we can set up a triangle in this circle and do some magical stuff, you know. So if you have a triangle here, the angle here would be the theta. That's like the x that we were dealing with from before. This is the angle here, right? So the angle is theta. This is x, the horizontal direction. This will be y, the vertical direction, or the opposite to the angle. And using our good friend Pythagoras again. How much time we can rely on Pythagoras in this video, boy? So Pythagoras is going to help you to solve what that is, right? The square root of the sum of the square of the other two sides. So that's that. Now this is why is this important. If I want to find the sine of this angle, it will actually be equal to the y over this, right? Now if we wander into the next quadrant, let's call that one the second quadrant. If we go into the second quadrant, you will realize that instead of x, we have negative x. The y is still going up, but the x is going backwards, so we'll have negative x. And if we try to find sine in this quadrant, it will still be y over x squared plus y squared. But if we try to find cos, remember cos, using this as the angle here, this is really the angle, but they are related. Using this as the angle, cos will be the adjacent over the hypotenuse. But what happened to our good friend the adjacent? He's negative, so the cos of any angle in the second quadrant is negative. Tan is negative as well, and this is where this came from. You may have heard A, S, T, C. All of the trigonometric ratios are positive in the first quadrant. Only sine is positive in the second quadrant. Only tan is positive in the third quadrant, and only cos is positive in the fourth quadrant. And to memorize this, some students use the saying all school teachers cuss. Not me. That's just the saying. If we venture into the third quadrant, we get this setup where this happens to be negative as well. So if the y is negative, when we start to find sine here, it will be opposite over hypotenuse, leaving a negative answer, cosine over hypotenuse, a negative answer. But what's something with tangent? The thing with finding the tangent of theta in this quadrant is that you have the opposite over the adjacent cancelling out each other and giving a positive answer. So that's why tan is positive here. Tan is the only one that is positive here, and the only one that will be positive in the next quadrant is cosine, and you can just verify that and see. If you want to get a little cleaner understanding of it, sine theta is positive in these two. Well, everybody is positive in the first quadrant. Everybody. Wow, look at this. This looks so nice. Sine is also positive here. Tan positive here. Alright, I think I talk enough about this. Let me move on. Why are you still here? Or all school teachers cuss, right? Not except Cohen Springer. Right? Question time. Let's see how some questions get pulled off with this. P negative 7 negative 4 is a point on the circumference of a circle with the center of the origin and makes the angle theta with the positive x-axis. So you have this quadrant, you have the positive x-axis is this part, and somebody making an angle theta with the positive x-axis. Hold up, I see negative and negative here, so I draw that in the wrong spot. So this is the positive x-axis, negative 7, negative 4, like you see that is somewhere down there. That is the big angle that thing making here, and you immediately need to know what quadrant this solely in, right? That's the whole. What are we going to do this question? And without using a calculator, find the values of sine theta, cos theta, tan theta. This could come for your exam. What are you going to do this question? Again, well, kind of hot in here. We are building up a sweat. The first thing I want you to do is draw your little quadrant diagram here. Now, this is for you. This is to help you understand. And your point always going on your little circle, wherever, right? So that's the kind of angle we're looking at there. Negative 7, negative 4. Yeah, right. You plot your little triangle in the inside. You sneak in a triangle on them there. And then you're ready to find whatever it is you want to find, and you could go ahead and find the little radius here, which is the hypotenuse. Call upon the power of Pythagoras' theorem and let him deliver that to you. Radius is equal to the sum of the square of the other two sides by Pythagoras' theorem. Make sure you state who you're talking about. You go ahead, you solve that. We get him equal to a nice little 65. Well, we'll say square root of 65. I hope these numbers correct here, because I really don't want to post no corrections and all kind of thing. And as I say, I don't have my calculator. So sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse. You're ready? We're writing all these things because we're ready to wet them down some answers here. Because we have all these sides now, we're just ready to perform. We're ready to perform. Sine theta is opposite over hypotenuse. This is the hypotenuse, that is the opposite. So you just do your thing. The rest is just elementary. You just let it take care of itself. And you go on with each one of those angles there, and those are your answers. Now, something about these answers though, you have your little square root of 65 and the underneath. You always need to see if you can, you know, simplify the surds or bring them on the numerator. And your technique for doing that is multiplying top and bottom by the same surd, 65. And I'm not really finding any square roots lying in the 65, so I think you could leave him like that. You should leave him like that and just go on with your life. That you get your marks, that is it day. So this is how you solve these questions. A lot of students don't know how to solve these questions. This is how you solve them. This is how you solve them. Taking another question, given that sine theta is equal to 3/5 and tan theta is less than 0. Find the value of cos theta and tan theta without you. This is the clue. Hey, stop. I kind of saw the answer there, boy. Okay, watch this. Sine theta is positive. Remember, you're always trying to find what quadrant this angle relaxing in. Theta, positive. Tan theta is less than 0. That is just code for negative. If you're less than 0, you're negative. So where is sine positive and tan negative? Only in the second quadrant, man. Sine is positive, tan is negative, theta is in the second quadrant. So you draw your little sketch. I didn't even bother to draw a circle this time because they didn't really talk about that. I put in my triangle, how I want to put my triangle. No, you can't pay a triangle, you want to pay a triangle. The tree here came from this as the opposite over the hypotenuse. So I know who to put where and what. I need to figure out this x. Square this, square that, take away Pythagoras term again. Figure out what x is. That's what this little calculation is about. Now x is really the plus or minus the square root of 16, yeah, but we had to work with the negative now. You know why you're working with the negative, right? Because they're going this way, away from the 0, and most students will just put 4 and get things wrong all over the place. But you know, yeah, it's in the second quadrant, so that is the whole business about finding the quadrant and verifying. And then you do the same thing we do last time. You work it out, you collect your marks, feel good about yourself. Look at that, another question. Given that theta lies between 0 and 2 pi, so anytime they say theta lies between a long range of thing, it could be that we're finding out a whole set of theta. And yes, right, so we need to find, it has a basic angle of pi and 5, so you know you're dealing with radians one time. They didn't even need to say radians. From the time you see pi in measuring an angle, is radians them soldiers talking about. And you need to find the corresponding angle in the second quadrant, third quadrant. This is like just testing your theory straight up here. You draw a little quadrant, you draw your angle, and then each angle, you realize that each angle is like this. And 180 take away pi and 5 will give me this angle. 180 plus pi and 5 will give me the third quadrant angle. And 360 take away pi and 5 will give me the fourth quadrant angle. Now I just say that normal, so but there's a key piece of knowledge that I need to know. A key piece of knowledge that you need to know is that if you were given like the basic angle, and this soldier is who we call the basic angle here, the angle in the first quadrant. If you want to find the other angles, it's a kind of symmetrical thing, you know. So how are we going to find this angle here, this long angle here? Well, angles on a straight line is 180. So 180 take away the basic angle will give me the angle in the second quadrant. Now people memorize our formula for this. I tell my students, you could watch the formula and learn the formula too, but it's better to know it from a graphical point of view and understand everything completely. That makes it easier for you to figure out questions when they try to test your logic and trick you up and things like that. This angle here is going to be the same pi and 5 here plus the 180. And if you're feeling to go into the next quadrant, it's going to be 360. I keep saying 180, but we're dealing with pi, right? So it's really 2 pi take away pi and 5. And when I say 180 take away pi and 5, it should be really pi take away pi and 5. So if you're in radians, stay in radians. If you're in degrees, stay in degrees. Sorry about that. I hope I do the correct thing in the working here. So in the second quadrant, and I color code this and thing because I had some time on my hands. pi, take away pi and 5, and notice how I simplified that there. Pi and 5, right? This is really 5 over 5, cancel here 1, you know. So 5 take away 1 is 4 pi and 5. Lay arithmetic B on point there, bro. Draw back the same thing, do back the same angle, add back the pi plus the basic angle. So yeah, I was adding the correct thing. I do the correct thing. And once again, you do it for this one. Alright, so this piece of theory that this piece of theory and these questions were designed to just firm up your understanding of trigonometry. This is like the middle of the syllabus in trigonometry. So this is the key part you need to get. You really need to understand quadrants. You really need to understand how we relate it to the graphs. You really need to understand how we relate it back to triangles, how we relate it back to sine, cosine, tangent. This is like the basic part here. And this will only become strong if you do lots of questions. You may have understood everything I showed you just now. You may have understood everything because, you know, it's me now. So you understood it, but that doesn't mean you could do it for your examiner. Don't think you could do that now. You need to actually go and do some questions that you have the answers for. Sit down and do the questions and you'll begin to run into little roadblocks. But it's better to get over those roadblocks now, them hurdles now, than when you're in your exam. So sit down and do lots of different questions and the types of questions. I try to vary it on the types of questions they could ask you on this. Oh my goodness, it's hot. My goodness. Alright. I tried to vary the questions so that you could get a good understanding of it, and I think this is, as I said, this would be really valuable for somebody who's really trying to revise this before exam. You could just roll this video up and just this video is for you. This video is for you. Alright, but we only reach halfway. Let me get the next half of your max. So let's take a closer look at the graphs. We have the sine graph. The sine graph, we were exposed to this already. You can take away some of the key points. Right underneath here, I have the radians compared to the degrees. The sine graph, you should get accustomed with this. Another thing to notice is that the sine and the cosine, you know, they're limited with that 1 and that -1. The sine of something would never be more than 1 or less than -1. It goes in between there. I wonder if I could write two things at the same time. Oh no, that is moving this way. Right. So that's the sine graph, and then you have your cosine graph, which looks like this. As I said, it's just off by, remember the sine graph went like this, and the cosine graph is like this. If I back it up, that's just the sine graph hiding there, you know. Right, it just starts differently. And your tangent graph is a really weird one because it's not really bounded by the 1 and the -1. It does some really weird stuff. So imagine these are the quarters, the quadrants, and I had the quadrants in the one before as well, you know, but I didn't really specify it. But the reason I draw them like this is because the tan graph, when I do something like this, it's just really freaky. That's your tan for you, doing that. It never meets. If you try to find the tan of 90 degrees, you maybe already know this. If you try to find the tan of 90 degrees, you're going to get a little error. Tan of 270 degrees, you're going to get error. Tan of pi and 2, 3 pi and 2, same thing, that's just radians, right? So you calculate have 3 modes: radian, gradient, and degrees. You want to make sure if you're in radians in your calculator, you're dealing with radians in the question, and then switch back to degrees. Don't make that elementary mistake of working out the whole question in degrees. Please don't make that mistake of working out a whole question only to find out your calculator in degrees. I mean, everybody has do that at some point in time. Try not to do that in your CSEC exam, my friend. That's not fun. That's not fun. What is this I'm drawing here? Sine of x is that. Yeah, but what about sine of 2x? And this is something you need to know. And I guess you can think about it logically. This means working out the sine of something that's twice the original something. So for example, if I want to get the sine of 2x and x happens to be what was this, 180, it means the 180 will come here. If x happens to be 2 pi, the 2 pi will go here. It's going to be like I'm squeezing in that graph. So I'll end up with a graph like that. The sine of 2x looks like that. You know, it still maintains the same 1, -1 height, but it gets squeezed in. And this comes in your multiple choice. Pure maths people, you'll see this in your multiple choice and thing as well, and you need to understand this a little better than just the add maths people. Like, you may need to understand further on what would happen if we have sine of 2 sine x, like the 2 is outside. What's going to happen to the graph? That's not really any add maths syllabus, but you can take a little peek. It's going to double like this, right? Okay, so that's it for graph. I really don't want to talk anymore about these graphs. So we can just have to see them in the questions when we start the past paper questions. Let me move on. Now this part is very important. Now I feel like I say that a lot of times in this video already, but this part is important. This is where we show the cos squared x plus sine squared x. Take a look at this. We have this triangle XYR. R is the hypotenuse. Theta, cos of theta will be the adjacent over the hypotenuse, which will be x over r. There, keep going. Sine of theta is going to be the opposite over the hypotenuse, which is going to be what? Which is going to be what? It's going to be y over r. I'm getting way too excited for this. By Pythagoras theorem, r squared is equal to x squared plus y squared. So these are the three things that you need to set up to prove that cos squared plus sine squared is equal to 1. You draw a little triangle and you work out what is the cos of theta using them variables there, and then you use Pythagoras theorem again, because apparently Pythagoras theorem could solve all the problems in the world. Alright, so cos squared theta plus sine, it's very late and I realize the later it is, the more cynical I get. Cos squared theta plus sine squared theta is equal to, well, there's a little substitution going on here in a pal. This went here, this went here, because this is cos squared, cos theta, so cos squared theta means I just square up what is this, you know, cos theta, cos squared, that squared goes there. Sine squared theta, this is sine theta, so that goes there, and I square it. And I get this, my friend. Now, what the hell is happening here? Oh no, this isn't finished. So r squared, blah 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 blah. Oi. So when this square, this means the square can go by the x and the r. That's how it works out here. Bam. Then common denominator. Bam. Then this is the magical part here. Isn't this x squared plus y squared equal to r squared? Isn't it? Isn't it? So that means I can just replace that with r squared. And r squared over r squared is 1. Therefore, cos squared theta plus sine squared theta is 1. Take your time. Right now, pull out a, if you haven't taken out a pen and a paper or a book by now and taking down notes and studying, I don't know what you're doing. I don't know. Best you come off of this video. No, let's come off this video. Press like before you come off the video. Alright, stay focused, stay focused. So compound angle formula is next. Excuse me whilst I take off some of the shine off my forehead. Forehead still shining. I'm looking at a little sunburn, but what you can do, boy? What you can do? Alright, compound angle formula. What's this exclamation mark? Sine A plus B. Just know these things. Sine A plus B is equal to sine A cos B plus cos A sine B. Notice this is positive, that is positive, because sine is work like this now. If it's sine A plus B, it's sine cos. When you see cos is a little different. But anyhow, we could combine this whole two things into one thing. And by the way, there's a proof for this. But we ain't really doing that proof now, because none of your syllabus, so why waste time on that? This video done long as hell. And sine A plus or minus So you see the plus or minus there, I just put it here, and plus or minus there, plus or minus. These things are in your formula sheet, but you know, it's good to have them in your mind. It makes it easier for you to do the question and see answers to the question. This is how cos looks. Now notice when it's cos, it's cos A, cos B. A and B was here, A and B go there. Now when it's sine, A, B, but it's sine A, cos B, cos A, sine B. It's weird. But the weirdness could help you memorize it. And also when it's positive, it's negative. When it's negative, it's positive. So when we combine it, the positive, negative on top, but negative, positive underneath there. But it's in your formula sheet, as I said. There it is. This is straight out of your formula sheet that you will see in your exam. That's right around the corner. Are you ready for that exam, man? Alright, so this is all the Gibbonian tricks right here. They give you some other stuff for vectors, circle, differentiation. This is not the complete formula sheet. We're missing a few things on the top and a few things on the bottom, but this video number formula sheet. And this is how the tan looks. The tan is really weird. You catch the idea, right? I just throw all the whole thing there one time. But you notice the positive, negative, but underneath is negative, positive. You basically find tan by dividing the first by the second. The first, the sine divided by the cos, and you get this kind of weird thing playing off here. Alright, let me see how this will come in a question. And hang on to the end of this video. I will be doing all the past paper questions in trigonometry ever from 2012 straight up to 2017, because I do the 2018 video already, and as I said, this video is very long and my eyes dropping on. Alright, find the exact value of cos of 105 tan 2 pi. So what you really want to do is split this angle here into two angles like 45 and 60. And since we already know how to do the cos of 45 and the cos of 60, we can do some exact values stuff. So 60, 45, use the cos of A plus B is that. And just simply substitute into the formula. And this is in degrees, so you can have some fun with that. Remember that the cos of 60 is a half. The cos of 45 is square root of 2 and 2. And we continue working out. And we'll get this. Did I double check this answer? No, I didn't. But it's looking good. So if I see a mistake, let me know. Alright. So yeah. Tan of 2 pi on 3. Same thing, my brother. 2 pi on 3 is really pi on 3 plus pi on 3, right? And pi on 3 is 180 divided by 3. You can think of it like that, which is 60 degrees. So this is the tan of 60 plus the tan of 60, or the tan of pi on 3 plus pi on 3. Some people think better in degrees. Most people think better in degrees. So you always need to kind of have this compared to the degree in your mind. This is really 120 degrees, 2 pi and 3 divided, you know, that kind of thing. And you just plug it into the equation, tan A, tan B, blah, 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 blah. And tan of pi and 3, most of the time they give you this in these questions. They'll say, given this, find that. Given that tan of pi and 3 is square root of 3, and cos of 60 is a half, and they'll say, given the initial things, and you have to find the ending things. Okay, we spend enough time on this. This is just simplification down to the ground there. Alright. So yeah, that looking correct. Next up, we got the double angle formula, which is just a modification of the compound angle formula. You see, sine 2a is this, cos 2a is that, tan 2a is this, and it's a modification of the compound angle formula. Instead of using a plus b, I use a plus a. Did I write it out? Yes, I did. So sine 2a is really sine of a plus a. You know, a plus a is 2a. And that will work out like this, which is really 2 sine a cos a, because you have a occurring all over the place there. So the sine 2a is simple, it's just that. But there's something to notice. There's something worthy of a few minutes in this video to talk about here, and that's cos 2a. When you do the cos 2a, right, we have them 2a's coming through there. What we ending up with is cos squared sine squared. Cos squared, let me see about this, I can't pass. So when you have the cos 2a, you have cos a plus a. Remember replacing the b, this was really b in the compound angle. We just really just doubling up on it. That's why I call it the double angle formula. Right? So cos a, sine a, cos squared a minus sine squared a. But this is not really useful when you're solving problems and equations and identities and things. This is not really useful because it's giving you 2 for the price of 1. You understand what I mean? You're getting a cos squared and a sine squared in the dance. We don't want that. You see all them little things that you'll be seeing flying across like mosquito, you know. Mosquito and thing. This back room is laden with mosquito. Anyway, so cos squared a minus sine squared a. I really break my concentration there. So it's not that useful to have a cos squared and sine squared together. So we get rid of it one time using this super formula now, boy. This formula here, cos squared a plus sine squared a is equal to 1. And rearrange, bring across the sine squared, and rearrange, bring across the cos squared. Because in one instance we can substitute for cos squared a and get this, and it will simplify to 1 minus 2 sine squared a. In the other instance we can substitute for sine squared a and get that. Notice the negative 1 will come here, but this is negative by negative, which is positive. So yeah, and get that. So 2 cos squared a minus 1. So it was worthy of a talk, and we talked about it, so we can move on. Tan of a plus a is that. We always leave in tan a in the end, just to you know, pick up the dregs. All your days, Tanny. Let's go on. Finally, the moment we have all been waiting for. The past paper questions, and those of y'all who fast forward the video straight up to this point, shame on you. Shame on you. You missed out all the beautiful theory. In fact, earlier in this video, I gave a clue in how I'm going to give away $10,000 to one of the viewers of this video. So you have to go back earlier in this video to be able to figure out what the clue is. Alright, so let's go on. 2012 question 4. 2012 question 4, we were asked to find the area of this weird looking shape here. It's a sector on a square. It don't get easier than that. We know how to find the area of a sector. We know how to find the area of a square. Oh, we asked for the perimeter of OACMN. OACM. That's the same shape too. So we have to find the area and the perimeter. The trickiest part might be the perimeter. Just remember, when you find any perimeter is 4, you have to get the length of that arc, and then you just add up these 3 sides. The working for that will look like this. The area of the wedge shape, we call it wedge shape now. Area of the wedge shape is the area of the square plus area of the sector. S squared plus half r squared theta, using the formulas from radians. Work it out, substitute, boom, substitute, boom, 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 boom. When you substitute it and you work it out, you're going to get this. By the way, it's a good idea to pause the video. I'm going to just do all the past papers in a row now. So it's a good idea every time I bring up a past paper, before you watch the solution, pause the video, do the question, then watch the solution. If you're revising before exams, that's the best thing. If you go in and sit down and watch me do all these questions, that's a good thing too, but it's not the best thing. So you want to do the best thing. Alright, moving on. So this is the total area here. Notice I left pi in the dance. We're not going to interfere with pi and make the whole thing look messy. They may be asked for it in the exact value. They may have asked and said, leave your answer in terms of pi. So you do that. Perimeter, remember we need to get the length of OANM. What the hell is that? OAN. AONM, that's this little part here. That is 4 by 4 by 4. I hope I put 4 by 4. Eh? Right, so that's 4 by 4, and then you need to get the length. Then you need to get the length of AC, which is the length of the arc AC. Right, and we got that. You will get this answer here. 5 marks. You can't tell me that's not nice, sweet. 5 marks. Easy. Next question. The next part of the question. Ha ha ha. We do some of this before. So once again, the people who speed up to the past papers, I hope all you know how to do this. Why do I have piece of the answer showing? Read the question. Somebody out there read the question for us. Given that sine of pi and 3 is equal to the square root of 3 over 2 cos blah blah blah. Them numbers just really phasing out right now, boy. Alright, let me see if what happening here. We were given the sine of pi and 3. Pi and 3 is really like 60 degrees. Pi and 3, 180 divided by 3. And we're supposed to know what 60 degrees is. Cos of 60 degrees. Sine of pi and 4, 180 over 4 again. Right? So 180 over 2 is 90 over 4, 45. So this is like the sine of 45 degrees. And they told us the square root of 2 and 2. And you're supposed to know this as well. So now that we know these things, without using a calculator, calculate the exact value of this. Now we need to find how we could split this up. Remember, you want to split this up into 2 parts or something. You need to figure out how to get this. We just do a question on this actually, just before. So cos of 7 pi on 12 is the same as pi over 3 plus pi over 4. That's 7 pi and 12. Yeah. And that's why they give us all this pi and 3 and pi and 4. Cos of pi 7 over 12 is the same as cos of pi and 3 plus pi and 4. You see, we split it up and now we're going to kill them with the compound angle formula. So by the way, you could think of this as 105 degrees, and that's how we get, alright, 7 on pi, 7/12 of pi. I think pi divided by 12, 180 divided by 12, 15 degrees, 7 by 15, 105. Okay, so you just work out that, use the double angle formula, substitute for all of these things, because we were given all of those things, and then substitute what these things are, because we were given what those things are, and you're supposed to know them anyhow. So that's there, work it out, and you get those answers. And the final question in 2010 was this identity question, which we spent a whole hour on talking about in identities last night in the live video. So we had lots of fun in that live video on identities, so you can go and check out that. So all the questions on identities I would have done already, but some tips to take about identities that we learned last night in the live video, that's 1 hour long, that you should go and check out if you want to get a complete revision of trigonometry, was that you pick the more complex side, or you pick the side that has 2 fractions or 2 terms. That's the side you normally pick, left hand side or right hand side, whichever side is the more complex side. You must have your algebra techniques down, like difference of 2 squares, distributive law, factorizing, multiplying numerator and denominator by the same term. We saw that happening a lot in the past papers, because we went through all the past paper identities over the last 7 years, 6 years. And you must work with purpose, working towards the side that you're trying to prove. That will help determining which decisions that you're making. And obviously use identities that simplify the process, reduce the terms by reducing the terms, or powers. By terms I mean, like if you have a sine and a cos, you want to change all of them to sine by some way or the other. If you have tan, change it to sine and cos. You're trying to simplify stuff. Enough about identities, let's look at the next past paper. In 2014 we are given a sector again, and this time we are given the perimeter of the sector, and we are asked to find the area. So you just have some substitutions to do. Perimeter, remember the perimeter is 2 times the radius times plus the arc length. You add up the radius and the arc length using the formula. Remember the formula for arc length is r theta. Substituting in values, we'll get this. If we substitute values for theta and we factorize out r, that's what happens. This means this is equal to what was given to us, right? Remember this came from here. We equate them and we solve for r. This gives r as 5. Now notice this neat little factorization thing that occurs here. When we bring this across, you understand? We get r by himself, but we saw that you have 12 plus pi and 2 plus pi and 6. So if I multiply 6 into this, it turns as 12 here, and the 6 goes from here. So boom, all of a sudden I could cancel out that. So this is one case where expanding helps simplify, and your algebra needs to be quick so you can see these little things popping out. And that will only come at practice. You need to practice these questions. Get some questions in the textbook, practice them, because this is probably one of the more trickier sector questions that came over the years. Once you find the radius, well, then it's simple now to find the area of the sector using the formula. This is the second part of the question. Yes, Melinda? There's a quadratic. You can just smell that quadratic here. You see that cos squared, you see that sine. But I try to put it in cos squared and sine to change up. So immediately changes cos squared to sine using the formula cos squared plus sine squared theta is equal to 1 cos squared theta plus sine squared theta is equal to 1. And you go along with that. So you substitute for cos squared here. This is going to give us 1 minus sine squared. And when I substitute and expand, I will get this. This is the quadratic I get, and I solve that quadratic. And this is a technique that you must know for your ADMATS exam, how to solve a quadratic involving trigonometric ratios. So this is like the midway question. So sectors, equation, and identity. So you're starting to catch the hang of how the past paper questions in trigs go. Simple way to solve this quadratic is to just make a little substitution for sine theta. Like say we let sine theta be equal to y. We form the quadratic equation like this. I know some of you all still having problems to solve quadratic equations if you see that negative by the a before the coefficient of the y squared or x squared term. If you see a negative there, you're still getting problems. So you must be able to solve quadratics. You see, quadratics is going to come all over your ADMATS paper. It's just going to be one star different quadratics equation, and you must be able to quickly solve quadratics. Otherwise, if you're still struggling to solve quadratics, ADMATS ain't going to be too nice for you, right? So looking in trigs, but you're having quadratics. Solving that, you'll get y is equal to 2, or y is equal to negative a half. But remember, we substituted for y. Y is really sine theta. So is either sine theta is equal to the 2 or sine theta is equal to the half. Now when sine theta is equal to 2, theta will be equal to the sine inverse of 2. Can't find the sine inverse of 2. No real solutions for that. But you can find the sine inverse of a half. We can find the sine inverse of a half. So keeping in mind that we need to get answers between 0 and 360 degrees. So because we're getting answers between 0 and 360 degrees, we need to find sorry, it wasn't a half, it was negative a half. We need to find where is sine negative. Since sine is positive in the first and second quadrant, it will be negative in the third and fourth quadrant. So those are the angles we're using. So we just get the basic angle and we just add on to 180 and minus from 360 to get the answer. And I explained how to do this earlier on in this video, in this very long video. So you could just drop back in the video and taking that. Alright, so it lies in the third and fourth quadrant. The basic angle is the sine inverse of a half is 30 degrees. So it's basically 180 plus 30 and 360 take away 30 would be the answers that are acceptable here. Once again, some people learn equations for this to figure out the two angles that you're using. That's okay, whatever floats your boat, but I'm saying that the best way to do this is know it graphically, know it in a very logical way, so that no matter how the question comes, you would be able to function. So you're hearing a kiskity, you're hearing a parrot curling, you're hearing cars driving, you're hearing people pounding out music, you're hearing a dog barking. Everything just happening every time I choose to record. But still we press. What's next? Oh, this identity, another identity that we did last night in the live. Now people start ringing bell and thing. It's our Baptist church next to I record everything. Right, so we did this identity live last night. So those who are in the... Sorry, this is not identity. The next part of the question, we make use of the compound angle formula. Remember, if you want to become really good at this, you may want to pause the video and try to attempt the question or think of how you do the question and then watch my solution. The way you do this is making use of the compound angle formula. You expand it and we're going to substitute for a half. So we expand that and we substitute there for a half and we simplify. We substitute also that tan theta is equal to 3. In everywhere we see tan theta, we put 3. Understand? And now all we left with is tan alpha. This boils down very quickly to 5 tan alpha is equal to 5. Tan alpha is equal to 1 when you bring across the 5. So alpha will be the tan inverse of 1, which is 45. and we wanted an angle between, or they said the value of the acute angle, so they didn't even give a range like 0 to 360. So just since it's just the acute angle we want, this question, which is worth 3 marks and seems like a very complex question, just watching at that like, whoa, that's deep. It's not that deep. We just expand and substitute and answers. But to know what to do and to have your brain sharp in the exam and not be fighting what part of the tricks is this again, what concept should I use here, you need to practice. You need to really practice the questions. How much time I say you need to practice in this video? I hope somebody feel that inside and really start doing some work and drilling and beating some book. Now you look at one more question. This is, I think this is 2015. 2015, find the area of sector OAB and find the area of the shaded region. So they're trying to be tricky in this question earlier. They're trying to be tricky. So it's a triangle, and now you need to find this shaded region here. This shaded region here. You need to find that. So you need to find the area of a triangle and the area of a sector, and all kind of simi-dimi taking place here. And then we have an identity, which we did last night. We do all the identities last night in the live. So go and check out that video. I'm not going to do it over. I might just show you the solution. And this here is double angle formula substitute. We just do this with the time. So double angle formula substitute. So pause the video, see if you can do this. Then go to the answers. Oh, this is just explaining the concepts. Once again, this is how you find the area of that. This is the formula you're going to use. And we went through how to solve that identity last night. Alright, so area of a sector, why is this background? Let's make this background white. So you find any area of the sector first, which is simple. Then we use tan theta because it's a right angle triangle. If you look carefully, you'll see that this is a right angle triangle. We want to find the length of maybe the base, so we could find the area of the triangle. So we find the length of the base, AC, is 7.58 centimeters. And now we can find the area of OAC, that triangle, using half base by height, right? Or we can find the area of one side and use half AB sine theta to find the area of the triangle as well. That's the next formula for finding the area of the triangle. Once you find the area of the triangle and you find the area of the sector, you take it away and you get the area of the shaded region. Simple. It looks simple here, but in the paper, trust me, it could have been problematic. So part B, given this, we need to show that this is what happens. So we just simply expand and substitute using the formula here now. Look what happens in part B. When we expand, we substitute with this x, this from what was given. Then we substitute for this here and this here because we are given that. Then we factorize out the half to make it be equal to the next side, because this is like if you have 1 over 2 here and this is like 1 over 2 here. This is not cos of this, this is cos x, and then multiply by that. So we can pull out a half from that very easily. And once you pull out the half, you'll be left with square root of 3 by cos x, take away sin x. And that's the same thing as let's check it quickly, as this side here. Half square root of 3 cos x sin x. Finally, the identity.
Hi, Daddy.
Pops, you riding your bike? Finally, this is the answer to the identity part in the past paper. And I explained this last night in the whole video. It's a very long video, but during the video I talked with students online live and we worked out the question together. So very quickly, we are required to prove this. I picked the right hand side. Although this side looks more complex, I picked the right hand side. The reason being that there's 2 terms here. Now I could have picked this side as well, but as I said, easier to make 2 into 1 than 1 into 2. Common denominator, multiply by 1 minus cos theta, which is a common thing that you do in solving identities. Multiply by something like the difference of 2 squares, so that happens there. Substitute sin squared theta, separate it. This part here is going to be equal to tan. This part here, the sin theta over cos theta, and that is the same as the left hand side. It's proven. Remember to practice a lot of identities. Every single identity that you could find between now and your maths exam, do it. So the next few papers I would have done in a live as well. So that kind of brings us to the end of all the past papers in tricks. So we've done tricks for AddMath. So if you watch all my video on tricks for AddMath, you should be ready. And you practice and you do some questions. That didn't win and take long. You could have a whole question writing tricks is question 4. You could have the whole of question 4 locked and ready for your AddMath exam. So this takes a lot of work to actually get this done. So make sure and press like and subscribe to show me some love. Show me some love. We're doing a crash course. The crash course is going to be online. So in the holidays, look out for that. Look out for the planning on that. Link up on my Instagram so you can keep in know of what things I'm doing to help students out here, to help them make it through the season. Right? My goal is to help students by either encouraging them, entertaining them, or educating them. There's a link in the description where you can download the entire maths course. An entire maths course. Check that out. And listen to this very carefully. Although the crash course is online, I'm going to have one day where all the students are going to come and I'm going to give them a prediction of what I think is going to come for CSEC Maths. And for those of you who were here since last year, you all know that I'm very good at predicting what happens. So you need to link up on my Instagram so you can know when it's time to register for that and where the location would be and what date and all the specifics. That is it, day. Bless up.